Please stop calling me a zebra. I truly like him calling me super powerful giraffe. So what as all of these, what do they stand for? Please means potassium. So potassium ion is the most electropositive ion, right? Sodium, potassium, sodium, calcium, magnesium, aluminium, the zinc ion. This is iron. This is tin. This is lead. This is hydrogen ion. Then this is copper ion. Then this is mercury. This is silver, and this is platinum, and G is gold. So this order, if I draw a line like this, this is the order of increasing electropositivity. So that means this is the most electropositive, this is the least electropositive. Now this is the order of discharge. So increasing order of discharge. So the increasing order of discharge is downward. That means this is higher. So ions that are lower in the series compared to those that are higher will be discharged. So we are looking at sodium and hydrogen. Look at the sodium and hydrogen ion. Look at sodium ion here, Na+. But look at hydrogen here, H+. So hydrogen is lower in the series compared to sodium. Therefore, hydrogen will be discharged. Because hydrogen will be discharged, so hydrogen will be the one to move to the negative cathode, while the sodium will remain in the solution. Right? So that is what you do for the electropositive ions. Then the second factor is the nature of the electrode. The nature of the electrode can determine who will be discharged. For example, when you are using copper electrode in copper sulfate ion, all right, the copper in the compound, copper sulfate compound, okay, that copper, because the electrode is copper electrode, to influence which ion will be discharged. So copper will naturally move out of that solution because of the presence of copper electrode. Preferential discharge at anode. Discharge at anode. How do you determine? The first thing you look out for is presence of halogen. So is there an halogen in the option? So you remember we did sodium chloride and water. So at this point, we have OH minus and chlorine. Is there an halogen here? Yes, chlorine is there. Halogens are group 7 elements. So when there is an halogen in the option, it is that halogen that will be discharged. So here, chlorine will be discharged. So presence of halogen. So halogen will be discharged. But in the absence of halogen, when there is no halogen, for example, if you are dealing with SO42 minus in water. Now here, there is no halogen in this two option. So who will be discharged? The rule says if there is no halogen, then it is your OH minus that must be discharged. And that OH minus will lead to the release of oxygen gas. So in the absence of halogen, OH minus will be discharged, leading to the release of oxygen gas. So this is the reaction. This OH minus will go to the anode, and this reaction will occur. So at the end, it's going to give us 4 moles of OH minus, 2H2O, and this. How many oxygen are here? 4. How many here? 2 plus 2, 4. How many hydrogen here? 4. How many hydrogen? 4. Equation is balanced. So this is what we are occur at the anode. You remember we said at the anode oxidation occurs. So how has oxidation occurred here? Oxidation number here